After 46 years of traveling through space, Voyager 1 finally sent back data from beyond our solar system that nobody saw coming. This isn't just another space mission update, it's a complete game-changer for everything we thought we knew about the universe. The tiny spacecraft has crossed into interstellar space and discovered an environment so strange and structured that scientists are, honestly, rewriting their textbooks. Get ready to have your mind blown by what's really lurking in the darkness between stars, because the truth is absolutely incredible.
The Great Silence and Revival.
Space exploration hit a terrifying moment in late 2023 when humanity's most distant messenger went completely silent. Voyager 1, our faithful explorer that had been sending data for nearly 5 decades, suddenly started transmitting nothing but garbled, meaningless signals. Engineers at NASA faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away. The culprit was a corrupted memory chip, likely destroyed by the same cosmic rays Voyager was studying. The fix required rerouting decades-old code into backup systems while dealing with a 22-hour communication delay. By April 2024, the impossible happened. Voyager came back to life, and what it began transmitting would change our understanding of space forever.
The Magnetic Revelation.
Something extraordinary happened when Voyager's magnetometer came back online. It revealed that space between stars operates by completely different rules. The spacecraft detected an interstellar magnetic field that's dramatically misaligned with our sun's magnetic influence, suggesting Voyager has encountered a galactic-scale boundary zone. These aren't minor variations. They're fundamental structural differences that point to magnetic turbulence zones where galactic fields twist and reconnect in ways scientists never predicted. The readings indicate Voyager might be navigating through invisible cosmic highways where magnetic forces create pathways and barriers throughout our galaxy. This discovery means the Milky Way has an underlying magnetic skeleton that influences everything from star formation to the flow of cosmic material, and we're only now getting our first direct measurements of this hidden architecture.
The Cosmic Storm.
The moment Voyager 1 crossed the heliopause in 2012, it encountered a radiation environment so intense it would be lethal to any human traveler. High-energy cosmic rays, accelerated to nearly light speed by distant supernovae and black holes, bombard the spacecraft at rates dramatically higher than anything measured inside our solar system. The jump wasn't gradual, it was like stepping through an invisible force field into a cosmic shooting gallery. These measurements reveal that our sun's protective bubble shields Earth far more effectively than anyone realized, creating a cosmic oasis in what's essentially a galaxy-wide radiation storm. The pattern of these particles isn't random either. Voyager has detected systematic variations suggesting natural radiation corridors that could represent the aftermath of ancient stellar explosions that shaped our galactic neighborhood millions of years ago.
The Whispering Void.
Forget everything you've heard about the silence of space. Voyager 1 has discovered that interstellar space is actually humming with constant activity. The spacecraft's plasma wave instrument detects persistent low-frequency oscillations that create a cosmic soundtrack most people will never hear. These aren't just random noise. They're organized pressure waves moving through space like invisible weather fronts. Multiple density spikes indicate Voyager is encountering shock fronts left behind by ancient supernovae that exploded thousands of years ago, with their energy still rippling through the cosmic medium. The most fascinating discovery is how layered this environment appears to be. Some regions are hotter, others denser, creating distinct climate zones in what we assumed was uniform emptiness. This cosmic weather system suggests interstellar space has its own complex meteorology.
Mapping the Invisible Galaxy.
Every data packet Voyager 1 transmits is helping scientists construct something unprecedented, a three-dimensional navigation map of interstellar space. The spacecraft has become humanity's anchor point for understanding the Milky Way's invisible infrastructure, measuring cosmic ray gradients, particle densities, and magnetic field orientations that reveal the hidden structure of our galactic neighborhood. This isn't theoretical modeling anymore, it's real-world cartography of the cosmos, like having a weather satellite for space between stars. The radiation mapping has profound implications for future human space exploration, as the intensity of interstellar radiation is far more dangerous than what astronauts encounter in Earth orbit. Understanding where natural shields and danger zones exist could determine whether humans can ever safely venture beyond our solar system, making Voyager's measurements crucial for planning humanity's next giant leap into deep space.
The cloudlet highway.
Since entering interstellar space, Voyager 1 has passed through at least 2 distinct interstellar cloudlets, regions where plasma, dust and gas density suddenly changes by factors of 2 to 3 times. These discoveries reveal that the space between stars resembles an ocean with currents, eddies, and weather patterns, rather than the uniform void astronomers once imagined. The probe's instruments show evidence of structured plasma ripples with clear boundaries and characteristics, suggesting large-scale organization in what scientists thought was chaos. NASA researchers now believe our sun is moving through the local interstellar cloud, with Voyager helping define its outer edges inside the much larger local bubble, an enormous cavity created by ancient supernovae explosions. These density shifts could affect Earth's exposure to cosmic radiation over millennia, as our solar system drifts through different interstellar environments, potentially influencing everything from cloud formation to biological mutation rates.
The galactic boundary zone.
So the transition from our solar system to interstellar space turned out to be, well, far messier and more complex than anyone predicted. Voyager 1 revealed that crossing the heliopause isn't like passing through a clean boundary. It's more like navigating a chaotic swirl of plasma, radiation, and magnetic forces that shift and change as our sun moves through the galaxy at 450,000 miles per hour. The boundaries Voyager crosses aren't fixed structures but dynamic zones that evolve constantly. Magnetic fields don't align as expected, radiation environments change dramatically over short distances, and plasma waves suggest ongoing activity that scientists are only beginning to understand. This complex interstellar weather creates an environment where the edge of our solar system becomes less of an edge and more of a turbulent frontier zone, where solar and galactic influences battle for dominance in an invisible cosmic wrestling match.
The ancient supernova trail.
The systematic patterns Voyager 1 detects in cosmic ray intensity and plasma density aren't just random fluctuations, they're actually geological records of our galaxy's violent past, written into the very fabric of space itself. The spacecraft appears to be following trails left behind by supernova explosions that happened millions of years ago, with their shockwaves still carving out pathways through the interstellar medium. These cosmic highways, you could say, channel high-energy particles along preferred routes, and that's what creates the radiation gradients and magnetic field orientations Voyager measures. Some astrophysicists even believe these ancient stellar explosion patterns might influence where new stars form in our part of the galaxy, with magnetic field orientations potentially guiding cosmic material into denser regions that could trigger future star birth. So, the data suggests Voyager isn't just sampling local conditions, it's really giving us a glimpse into the aftermath of cataclysmic events that shape the structure of our entire galactic neighborhood over, well, cosmic timescales.
The eternal ambassador.
While Voyager 1's scientific mission might end within a few years as its power source slowly fades, the spacecraft's journey through eternity is actually just beginning. This small probe will keep silently coasting through the cosmos long after human civilization has either evolved beyond recognition or, disappeared entirely. In about 40,000 years, Voyager will make its closest approach to Gliese 445, a red dwarf star, passing within about 1.6 light-years. It's kind of like a celestial handshake across the vastness of space. The golden record attached to Voyager carries sounds, music, greetings in 55 languages, and 116 images from Earth, all engineered to survive over 1 billion years in the harsh environment of space. This makes Voyager not just a scientific instrument, but possibly the most enduring monument humanity will ever create, carrying the essence of our species into the cosmic deep, long after Earth's continents have shifted beyond recognition.
The real discovery.
The most profound revelation from Voyager 1's journey isn't about discovering aliens or wormholes. It's really about understanding that interstellar space is a dynamic, structured environment all its own, with weather patterns, magnetic topography, and radiation zones. The spacecraft revealed that our solar system exists within a kind of protected oasis, with the sun's heliosphere shielding us from an environment that's way more intense and radiation-filled than anyone realized. The transition to interstellar space isn't simple, it's messy and complex, with magnetic fields that don't line up the way we expected, and plasma waves that show constant activity. The interstellar medium has layers, fronts and boundaries that shape the invisible architecture of our galaxy. Most importantly, Voyager showed us that we live in a cosmic shelter. Our solar system isn't just our home, it's really our sanctuary in a galactic storm raging beyond our protective bubble, making Earth even more precious than we ever imagined. So there you have it. Voyager 1 didn't just reach the other side, it discovered that the other side is nothing like we expected. Which part surprised you the most about interstellar space? Let me know in the comments below. If you enjoyed learning about humanity's greatest space exploration achievement, make sure to like this video, share it with someone who loves real science as much as you do, and don't forget to subscribe to Sci and Y for more mind-blowing discoveries about our incredible universe. Until next time, keep questioning and keep exploring. What if NASA found conclusive proof of alien technology, but decided to hide it from the world? 3 weeks ago, a hacker group calling itself Event Horizon claims to have done the impossible, pulling 24 gigabytes of classified mission data from NASA's secure servers. The target? A mission to intercept 3I Atlas, the third interstellar visitor ever detected. The files hint at a cover-up of cosmic proportions. So what did they find that was so disturbing? Let's explore this together. Event Horizon's cyber attack. So how does a clandestine group get its hands on NASA's crown jewels? According to the leaked security logs, this wasn't a brute force attack, it was surgical. In the early hours of September 2, 2025, Event Horizon executed a coordinated cyber attack that bypassed multiple layers of agency firewalls. They exploited a zero-day vulnerability in an outdated Fortran-based mission planning module, a tiny crack in an otherwise formidable digital fortress. The transfer rate was a blistering 571 megabits per second, far too fast for automated security flags to catch in time. Forensic analysts later pieced together a chilling timeline. The attackers gained initial access at 3:14 a.m. Eastern, escalated their privileges to the highest level by 3:19, and began siphoning data at 3:23. In under 7 minutes, 24 gigabytes of compressed files, including internal chat logs, draft reports, and sensitive telemetry from the 3I Atlas intercept mission, were gone. By 3:30 a.m., the connection vanished, leaving behind nothing but a silent gap in the audit trail. Cybersecurity expert Mikko Hipponen has stated that such an attack would require nation-state-level resources, suggesting Event Horizon is far more sophisticated than a typical hacktivist group. The manifesto and distribution. A successful hack is one thing, but what you do next is everything. Hours after the breach, a manifesto from Event Horizon appeared on encrypted forums accessible only through the Tor network. They claimed full responsibility, framing the attack not as an act of digital vandalism, but as a necessary response to what they termed unlawful, cosmic secrecy. Their message was a direct challenge to the global intelligence status quo, echoing the methods of groups like WikiLeaks but with a far more specific target. They warned that the leaked files contained material so sensitive that even senior directors at NASA were allegedly kept out of the loop. Their language was blunt. The world deserves to know what its own scientists have found. But Event Horizon didn't just dump the data online. Instead, they began a calculated campaign, distributing blurred screenshots and heavily redacted memos to select journalists and online channels known for covering classified science. No one received the full archive. It was a strategic drip feed, designed to build pressure and credibility, giving the world just enough of a glimpse to understand the immense gravity of what had been taken. Their final warning was a gauntlet thrown down. The files contain evidence that will force the public to confront a new reality. Authenticating the documents. In the world of leaks, authenticity is paramount, so are these files real? The evidence presented by Event Horizon is compellingly layered. The leaked screenshots are plastered with authentic details, bold, block-lettered confidential stamps, thick redaction blocks, and metadata tags showing UTC timestamps that perfectly match the breach window from NASA's own security audit. We see mission patch artwork in the corners, a stylized comet labeled 3I Atlas Int. Every document carries unique identifiers, routing codes, and internal chat handles you'd expect to see inside a major agency. Technical diagrams and draft tables use Courier font headers and bear NASA's internal digital watermark. We even see screenshots of the classic blue and white NASA email interface, with subject lines like Atlas Intercept Immediate Action Required, and Telemetry Review Anomaly Detected. One partially blurred memo lists technical trajectory data, while another redacted report is marked with the access level TSSCI, denoting top secret sensitive compartmented information, a classification that restricts access to a small, specific group of cleared individuals. The documents bear digital signature strings ending in JPL for the Jet Propulsion Laboratory, and GSFC for the Goddard Space Flight Center, indicating a multi-center collaboration. Discovery of 3I Atlas. Before the leak, there was the discovery. On July 1, 2025, the real-life Atlas survey in Hawaii, a NASA-funded planetary defense system officially known as the Asteroid Terrestrial Impact Last Alert System, logged a new object tearing through the solar system at an astonishing 130,000 miles per hour, or about 58 kilometers per second. Astronomers immediately flagged it. This was the third interstellar object ever detected, following the bizarre one I/Oumuamua in 2017 and the more conventional two I/Borisov in 2019. But 3I Atlas was different. Early estimates put its size at a staggering 26 kilometers across, roughly the size of the asteroid Vesta, and over 25 times longer than Oumuamua. Its trajectory, calculated by the Minor Planet Center, confirmed it was an interstellar visitor on a one-way ticket through our system, with an orbital eccentricity greater than 6.0. Its path was hyperbolic, meaning it wasn't captured by our sun's gravity and would not be coming back. According to Dr. Larry Deneau, the principal investigator for the Atlas project, an object of this size and velocity is a once-in-a-century detection event. This wasn't just another icy rock, it was an unprecedented anomaly from deep space. Impossible physics and trajectory. Here's where the story takes a sharp turn from unusual to unbelievable. Like its predecessor Oumuamua, 3I Atlas was not behaving according to the laws of physics. The leaked mission logs from July 18, 2025, show a sudden, inexplicable sideways acceleration resulting in a velocity change or delta V of 1.5 meters per second. The object changed course in a way that defied gravitational models. For a normal comet, such a deviation could be explained by outgassing, measured by the non-gravitational acceleration parameter A2. However, just like with Oumuamua, initial observations of 3I Atlas showed no cometary tail, no dust, and no gas coma to account for the push. Its A2 parameter was effectively zero, yet it was still maneuvering. Trajectory analysts were stumped. They ran models accounting for solar radiation pressure, gravitational pulls from planets, and every known natural force. Nothing matched the telemetry. Dr. Amy Mainzer, a leading expert on asteroids, has noted that explaining such a deviation without observable outgassing requires, quote, exotic physics or an artificial origin. The numbers kept pointing to a single, unsettling conclusion. Some force other than gravity was steering this massive object through our solar system. Surface anomalies, the armor problem. When the first high-resolution images from the Intercept mission were allegedly taken, the mystery of 3I Atlas deepened. The object's surface looked nothing like any known comet or asteroid. Analysts flagged a disturbing pattern. Bands of smooth, almost metallic-looking plating, broken by lines that ran too straight and were too evenly spaced to be natural fractures. These weren't the chaotic, jagged fissures seen on Comet 67P by the Rosetta mission. They were seams, crisscrossing the surface in a deliberate grid. One analyst, in a leaked internal chat, dubbed it the radiator problem, referring to a network of raised ridges spaced like the cooling fins on a spacecraft. These ribs cast long, uniform shadows, and their regularity was so pronounced that pattern recognition software reportedly flagged them as artificial. The object's albedo, or reflectivity, was measured at 0.7, closer to polished metal than the asphalt dark surface of most comets, which have an albedo below 0.05. Planetary geologist Dr. Carolyn Porco has emphasized that nature does not produce such perfect, large-scale geometric patterns. This wasn't just an odd rock, the leaked images suggested it might be wearing armor. Thermal signatures and heat pulses. If the surface looked engineered, the thermal data was even more alarming. According to the leaked files, infrared arrays recorded heat vents pulsing with incredible regularity. The logs show heat pooling along the strange, ribbed seams and then bursting outward in tight, directed jets. This wasn't the broad, chaotic outgassing you see in a typical comet. These were discrete, timed pulses occurring precisely every 90 seconds, raising local surface temperatures by over 200 degrees Kelvin in an instant. The mission logs classified this as a directive motion event, a term typically reserved for spacecraft thrusters, not natural phenomena. Even more damning, trajectory analysts correlated these thermal pulses directly with the object's mysterious course corrections. After each 90-second heat burst, the intercept team logged a subtle but precise shift in its path. The efficiency of this propulsion, measured as specific impulse, was calculated to be far beyond any chemical rocket, consistent with advanced ion or plasma thrusters. Gravity couldn't explain it, solar radiation is constant, and natural outgassing is random. The evidence was building 3. I-Atlas wasn't just moving strangely, it appeared to be actively propelling itself. Chemical composition mysteries. The story gets even stranger when you look at the chemical makeup. According to a leaked memo from the Goddard Space Flight Center, the first full infrared spectrum analysis of 3 I-Atlas yielded a bizarre result. The spectra lit up with incredibly sharp lines of nickel. Now, nickel itself isn't entirely unusual in space rocks. It's often found in iron-nickel alloys. But here's the kicker. In the data for 3 I-Atlas, the signature for iron was almost completely absent. In the entire catalog of known asteroids and comets, a composition of refined nickel without its constant companion, iron, is unheard of. Furthermore, the memo noted the absence of common silicates and carbonaceous compounds. Meteoritics expert Dr. Meenakshi Wadhwa has confirmed that such a separation of nickel from iron requires industrial-scale processing at very high temperatures, a process not known to occur in nature. It suggests a material that has been engineered, not one that formed naturally. The memo was allegedly sealed within hours under a restricted access embargo, but the data was clear. An object with an artificial structure was made of an equally artificial material. Radio echoes and communication patterns. Beyond its motion and materials, the most chilling evidence in the leaked files points toward active technology. According to the logs, radio astronomers reviewing raw data from the intercept mission flagged a pattern of faint, repeating echoes in the X-band frequency range. These weren't natural radio bursts or cosmic static, they were precise, clipped signals with a high signal-to-noise ratio, bouncing back from 3 I-Atlas at regular intervals. What made this truly shocking was the timing. The interval of the radio echoes mapped almost perfectly to the 90-second rhythm of the object's thermal pulses. It was as if something was pinging the object, and the heat pulses were the response. In one of the leaked chat logs, a veteran telemetry specialist reportedly wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." This completely changed the nature of the investigation. SETI pioneer Dr. Jill Tarter has long argued that a truly intelligent signal would likely be efficient and information-dense, characteristics that align with these alleged repeating echoes. The data suggested it could be an active, responsive probe. Expert analysis and propulsion theory. This is where a very real and very famous scientist enters the picture, Harvard astrophysicist Avi Loeb. While he has not commented on this alleged leak, his previous analysis of Oumuamua via the Galileo project provides a stunning framework. The leaked analysis of 3 I-Atlas goes even further than Loeb's theories. The directed heat pulses and course corrections are consistent with a sophisticated ion drive or a similar propulsion system. But the alleged smoking gun came from a microscopic fragment recovered by the interceptor's dust collector. Under an electron microscope, technicians reportedly saw a lattice of silicon with doped traces of phosphorus, arranged in layers spaced at micron intervals, identical to the architecture of a semiconductor wafer, with visible p-n junctions. A materials scientist would immediately recognize this structure. No known natural process from supernova shock waves to planetary formation can create such ordered, layered microstructures. The memo's summary line, though partially redacted, was legible. Semiconductor structure detected. Artificial origin cannot be excluded. This single finding, if true, moves the conversation from anomaly to artifact. So, what do we make of all this? A 26-kilometer object from another star system moving at impossible speeds, making its own course corrections. It has a surface that looks like armor, a composition of refined nickel, and it pulses with heat and radio echoes on a perfect 90-second clock. And finally, there's a fragment of what appears to be a microchip. The leaked files, if authentic, present a disturbing and profound reality. The questions are staggering. What is this object's purpose? Where did it come from? And perhaps most importantly, what else has NASA found that we don't know about? Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching Sci and Why.
Welcome to Sci and Why, where we decode the mysteries of our universe through rigorous scientific analysis. Today, we're investigating the enigmatic interstellar visitors that have astronomers worldwide questioning everything we thought we knew. From the puzzling Oumuamua to the massive newcomer 3I Atlas, these cosmic wanderers challenge our understanding of what's possible in the vast expanse of space. Join us as we explore the data, examine the theories, and ask the fundamental question, are we alone? Oumuamua Discovery and Anomalies. In October 2017, the Pan-STARRS survey in Hawaii detected something unprecedented: Oumuamua, the first confirmed visitor from another star system. This elongated object, measuring approximately 800 meters in length with an extreme 10:1 aspect ratio, defied all known classifications of celestial bodies. What truly baffled scientists was its unexplained acceleration away from the Sun without any detectable cometary outgassing or tail formation. Traditional physics couldn't account for this behavior, leading to intense scientific debate. Harvard astrophysicist Avi Loeb proposed the controversial hypothesis that Oumuamua might be an artificial light sail constructed by extraterrestrial intelligence. Other researchers suggested more conventional explanations, including exotic compositions like hydrogen or nitrogen icebergs. However, each natural explanation faced significant challenges when confronted with observational data. The object's discovery fundamentally altered our approach to studying interstellar space, revealing that the void between stars isn't as empty as previously believed. Despite extensive analysis using multiple space and ground-based telescopes, Oumuamua's true nature remains one of astronomy's greatest mysteries. UFO and UAP encounters and theories. The scientific community has increasingly focused on unidentified aerial phenomena following credible reports from U.S. Navy personnel. The most documented case was in 2004, an encounter with the infamous Tic Tac object off California's coast. This white, featureless craft demonstrated flight characteristics that violate known aerodynamic principles, including instantaneous acceleration and seemingly impossible maneuvers. Multiple radar systems tracked the object simultaneously while trained pilots provided visual confirmation. Some researchers have proposed advanced theories to explain these phenomena, including plasma-based holographic projections or exotic propulsion technologies. The physics of such systems would require manipulation of electromagnetic fields on scales currently beyond human capability. Government acknowledgement of retrieved crashed objects has added credibility to these reports, with intelligence sources confirming multiple recoveries. The correlation between increased UAP sightings and humanity's growing space-based observation capabilities raises intriguing questions about potential monitoring activities. Advanced civilizations might employ sophisticated surveillance technologies to assess emerging technological species without direct contact. Bob Lazar analysis. Bob Lazar's claims about reverse-engineered extraterrestrial technology at Area 51 have influenced UFO research for decades, despite ongoing scientific skepticism. His detailed descriptions of anti-gravity propulsion systems powered by element 115 seemed purely fictional in the 1980s, yet this super-heavy element was successfully synthesized in laboratories in 2003. Lazar described witnessing craft that manipulated gravitational fields through bombardment of element 115 with protons, creating localized distortions in spacetime. While his educational credentials remain unverifiable and security clearance claims are disputed, some aspects of his technical descriptions align with emerging theoretical physics concepts. The Alcubierre warp drive equations, published after Lazar's claims, describe similar spacetime manipulation techniques for faster-than-light travel. Modern physics recognizes that gravity is indeed a manifestation of curved spacetime, making field manipulation theoretically possible with sufficient energy control. However, the energy requirements for such technologies would exceed current human capabilities by orders of magnitude. Lazar's influence on UFO culture persists because his descriptions aren't entirely inconsistent with advanced theoretical physics. Light sail hypothesis. Professor Avi Loeb's revolutionary light sail hypothesis represents a paradigm shift in how we interpret anomalous astronomical observations. His mathematical analysis demonstrates that radiation pressure from stellar light could account for Oumuamua's mysterious acceleration if the object possessed specific physical characteristics. For photon pressure to explain the observed forces, the object would need to be extremely thin, less than a millimeter, while maintaining structural integrity across interstellar distances. This requires materials with strength-to-weight ratios far exceeding natural substances, suggesting advanced engineering. Loeb's calculations show that such a sail could maintain stable flight patterns across vast cosmic distances, making interstellar travel feasible for sufficiently advanced civilizations. The hypothesis gained attention because it elegantly resolves the contradiction between Oumuamua's acceleration and lack of visible outgassing. Critics argue that natural explanations involving exotic ices remain more probable, but Loeb maintains that scientific objectivity demands consideration of all possibilities. His work has reinvigorated the search for extraterrestrial intelligence by demonstrating how conventional astronomical surveys might detect technological signatures from advanced civilizations. 3I Atlas, the new discovery. The discovery of 3I Atlas in early 2025 by the Asteroid Terrestrial Impact Last Alert System has sent shockwaves through the astronomical community. Initial observations suggest this interstellar visitor measures between 10 to 20 kilometers in diameter, making it potentially 200 times larger than Oumuamua, a size disparity that challenges statistical models of interstellar object populations. The object's velocity exceeds 60 kilometers per second, confirming its extrasolar origin through hyperbolic trajectory analysis. What makes 3I Atlas particularly intriguing is its unusual brightness and spectroscopic signatures suggesting metallic surface composition inconsistent with typical asteroids or comets. NASA's James Webb Space Telescope has detected infrared emissions indicating possible thermal management systems and structured materials. Unlike natural objects that should tumble chaotically through space, 3I Atlas appears to maintain stable orientation and controlled energy output. The statistical probability of discovering such a massive interstellar object as only our third detection approaches astronomical improbability. Advanced spectroscopic analysis reveals isotopic ratios unlike any solar system materials, supporting theories of formation in drastically different stellar environments. Atlas Telescope System. The Atlas network represents a revolution in automated astronomical surveys, utilizing 4 strategically positioned telescopes across Hawaii, Chile, and South Africa to monitor the entire visible sky. Each telescope, despite its modest 0.5-meter aperture, employs cutting-edge CCD arrays and sophisticated software algorithms capable of detecting objects moving against the stellar background. The system's strength lies in its temporal resolution. Scanning the complete sky every 24 hours enables detection of extremely fast-moving objects that traditional surveys would miss. Atlas technology, developed through collaboration between the University of Hawaii and NASA's Planetary Defense Coordination Office, processes millions of astronomical images using machine learning algorithms trained to identify anomalous motion patterns. The detection of 3I Atlas demonstrates the system's capability to catch interstellar visitors early in their solar system transit, providing crucial observation time before they disappear into deep space. Real-time data processing flags suspicious objects within hours of detection, triggering follow-up observations from major observatories worldwide. This automated approach has transformed asteroid detection from periodic manual surveys to continuous automated monitoring. Scientific theories and debates. The scientific community remains fractured over explanations for 3I Atlas's anomalous properties, with competing hypotheses attempting to reconcile observational data with known physics. The hydrogen iceberg theory proposes the object consists of solid hydrogen formed in the frigid depths of interstellar space, though this model struggles to explain structural stability over millions of years. Alternative nitrogen sublimation models suggest composition similar to Pluto's surface, potentially explaining observed outgassing without visible tail formation. Dr. Alan Fitzsimmons leads the natural origin camp, emphasizing the need for comprehensive spectroscopic data before considering exotic explanations. Conversely, advocates for expanded theoretical frameworks that might accommodate artificial construction scenarios. The fundamental problem remains the inconsistency between observed acceleration patterns and minimal detectable volatile emission, a contradiction that challenges basic cometary physics. Statistical analysis reveals the probability of discovering such a large object through random interstellar encounters approaches negligible values, forcing scientists to question either our understanding of object size distributions or the randomness of these visits. Future detection technology. The Vera C. Rubin Observatory in Chile represents the next generation of astronomical detection systems, featuring an unprecedented 8.4-meter primary mirror coupled with the world's largest digital camera. This technological marvel captures images spanning 40 full moons per exposure while maintaining resolution sufficient to detect objects smaller than previous generation surveys. The Legacy Survey of Space and Time will systematically photograph the southern sky every few nights for a decade, creating a comprehensive temporal database of cosmic changes. Advanced machine learning algorithms process this massive data stream in real time, identifying asteroids, transient events, and anomalous objects within hours of observation. The system's enhanced sensitivity will enable detection of interstellar visitors when they're still months or years from closest approach, providing unprecedented preparation time for detailed study campaigns. Rubin's statistical power promises to resolve fundamental questions about interstellar object populations by discovering dozens of new visitors annually rather than the current rate of one every few years. This technology will either confirm that objects like 3I Atlas represent statistical outliers or reveal a previously hidden population. Theoretical implications. The implications of discovering objects like 3I Atlas extend far beyond astronomy into fundamental questions about intelligence in the universe. SETI researchers are developing protocols for analyzing these visitors' behavior patterns for signatures of intentional control or embedded communications. The concept of galactic probe networks gains credibility when considering the efficiency of automated exploration versus biological travel across interstellar distances. Advanced civilizations might deploy self-replicating surveillance systems throughout the galaxy, monitoring emerging technological species while maintaining strategic distance. Theoretical models suggest such networks could map entire galactic regions over millions of years, creating comprehensive databases of planetary development. The timing correlation between humanity's space-age emergence and increased interstellar visitor detection rates raises intriguing questions about causation versus coincidence. Cosmic archaeology theories propose that evidence of ancient civilizations might be found in the form of derelict probes or monitoring stations throughout our galactic neighborhood. These discoveries force reconsideration of humanity's cosmic significance. We may not be isolated observers but subjects of ongoing study by intelligences that achieved technological maturity eons before our species emerged. Future endeavors. The European Space Agency's Comet interceptor mission represents humanity's first attempt at planned rendezvous with an interstellar visitor, utilizing advanced trajectory prediction and rapid deployment capabilities. International coordination between ground-based observatories and space-based assets is evolving toward real-time global response networks capable of comprehensive data collection from future encounters. NASA's proposed rapid response spacecraft concepts could launch within months of detecting new visitors, using ion propulsion and gravitational assists to achieve intercept trajectories before objects exit our solar system. Project Lyra, designed to pursue Oumuamua, demonstrates the technical feasibility of interstellar chase missions using current technology and careful orbital mechanics. Advanced sample return capabilities would enable direct analysis of interstellar materials, potentially revealing formation conditions in alien star systems or evidence of artificial construction. Future missions will deploy sophisticated spectrometers, mass analyzers, and imaging systems capable of determining composition, structure, and origin with unprecedented precision. These endeavors mark humanity's transition from passive observation to active exploration of interstellar phenomena, potentially yielding definitive answers about the nature of these mysterious visitors. The scientific investigation of interstellar visitors like 3I Atlas continues to challenge our understanding of the cosmos and our place within it. As detection technology advances and analytical methods improve, we stand on the threshold of potentially revolutionary discoveries about our galactic neighborhood. Whether these objects represent exotic natural phenomena or evidence of cosmic intelligence, they've already transformed how we approach the study of our universe. The data keeps coming, and the questions keep getting more profound. Keep exploring with Psi and Y as we decode the mysteries that surround us and push the boundaries of human knowledge into the unknown.
When NASA's computers started receiving impossible data from the edge of our solar system, scientists couldn't believe what they were seeing. After 47 years of silent travel through the cosmic void, Voyager 1 has transmitted discoveries that challenge everything we thought we knew about interstellar space. Today, on Psi and Y, we're unveiling the shocking revelations that have left astronomers questioning the very nature of our universe. From mysterious humming sounds to unexplained cosmic phenomena, these findings will change how we view our place in the galaxy forever. the impossible mission that defied all odds. Voyager 1 was designed to last just 5 years, yet it's still transmitting data after nearly half a century, making it humanity's most successful space mission ever. In 1977, NASA launched what seemed like a routine planetary exploration mission. Voyager 1 and its twin, Voyager 2, were built using 1970s technology with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo today. Originally designed to study Jupiter and Saturn during a rare planetary alignment, these spacecraft were expected to go silent by 1982. Instead, they embarked on humanity's greatest journey into the unknown. The mission capitalized on a once-in-176-year gravitational alignment that allowed the spacecraft to use planetary gravity as cosmic slingshots, accelerating them toward the outer solar system. What began as a 5-year mission has become a 47-year odyssey that redefined our understanding of space. Today, Voyager 1 travels at 38,000 miles per hour through interstellar space, sending back data from regions no human-made object has ever explored. The fact that this 1970s technology continues functioning in the harsh environment of deep space represents one of engineering's greatest triumphs. Crossing the final frontier into interstellar space. On August 25, 2012, Voyager 1 became the first human-made object to leave our solar system, entering a realm where the sun's influence ends and true interstellar space begins. The moment Voyager 1 crossed the heliopause, the boundary between our solar system and interstellar space, marked a historic milestone for humanity. At 11 billion miles from the sun, the spacecraft detected a dramatic change in its environment. The solar wind, a stream of charged particles flowing from our star, suddenly dropped to nearly zero, while cosmic radiation increased threefold. This transition wasn't gradual, it was like stepping from a protected harbor into an open ocean. The heliopause acts as our solar system's shield, protecting us from the galaxy's intense radiation. Beyond this boundary lies the interstellar medium, a vast expanse filled with remnants from ancient star explosions, cosmic dust, and mysterious phenomena that scientists are only beginning to understand. Voyager 1's instruments detected strange magnetic field fluctuations and unexpected particle densities that contradicted existing models. The spacecraft found itself in an environment where the familiar rules of our solar system no longer applied. This crossing represented more than a technical achievement. It was humanity's first step into the galactic neighborhood, opening a new chapter in space exploration.
The mysterious humming sound from the void.
Voyager 1 detected a low, persistent humming sound in the supposed silence of interstellar space, a discovery that has scientists completely baffled about what's creating this cosmic symphony. In the vacuum of space, sound shouldn't exist. Yet Voyager 1's instruments detected something extraordinary, a continuous, low-frequency humming emanating from the interstellar medium itself. This wasn't sound as we understand it on Earth, but rather vibrations in the sparse gas and plasma that fills the space between stars. The humming appears to be generated by the interstellar medium's interaction with cosmic phenomena, creating a kind of cosmic background music that permeates our galaxy. Scientists describe it as similar to the sound of wind through trees, but occurring in a medium millions of times thinner than Earth's atmosphere. The discovery challenges our understanding of how energy propagates through space, and suggests that interstellar space is far more active than previously thought. These vibrations might be caused by stellar winds from distant stars, shockwaves from supernovae, or even more exotic phenomena we haven't yet identified. The humming varies in intensity and frequency, suggesting it responds to changes in the local interstellar environment. This cosmic soundtrack provides scientists with a new way to study the structure and dynamics of our galaxy, turning Voyager 1 into an interstellar seismograph.
The heliopause's shocking behavior.
The boundary of our solar system isn't the stable barrier scientists expected. Instead, it's moving, shifting, and behaving in ways that completely contradict our models of how space works. The heliopause, which is our solar system's protective boundary, has revealed itself to be way more dynamic and unpredictable than anyone imagined. Rather than maintaining a steady position, this cosmic border actually fluctuates dramatically, sometimes moving billions of miles in relatively short periods. Data from Voyager 1 and 2 shows the heliopause exhibiting strange angles and irregular shapes that just defy current theoretical models. Back in 2014, NASA's Interstellar Boundary Explorer satellite detected unusual brightening of energetic particles, which suggested massive disturbances in the boundary region. These irregularities simply don't match existing predictions about how the solar wind should interact with interstellar space. The heliopause's movement might even explain why Voyager 1 and 2 reached interstellar space 6 years apart, even though they followed similar trajectories. Scientists have observed the boundary creating shock waves and turbulence that ripple through both the solar system and interstellar space. This dynamic behavior suggests our solar system is more like a living organism than a static structure, constantly responding to galactic forces we're only beginning to understand. The implications are pretty profound. If our solar system's boundary is this unstable, what does that mean for the protection it provides against cosmic radiation?
Electronic confusion in the cosmic deep.
So, in May 2023, Voyager 1 began transmitting garbled, incoherent data instead of scientific measurements, as if the spacecraft was suffering from electronic dementia in the depths of space. 46 years into its mission, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude articulation and control system started sending random, meaningless data instead of coherent status reports. From Earth's perspective, it honestly looked like Voyager 1 was losing its ability to communicate effectively, much like how a person with aphasia struggles to form coherent sentences. The mystery deepened when engineers realized that, despite the garbled communications, Voyager 1's radio signal remained strong and stable, which meant the spacecraft was still functioning normally. Its scientific instruments just kept operating without any awareness of the communication problem, and the fault protection system, designed to put the spacecraft in safe mode during emergencies, never activated. After a lot of investigation, NASA discovered the problem. The control system had switched to a computer that had been dormant for years, basically trying to use obsolete hardware to process modern commands. The solution required sending precise instructions across 15 billion miles of space to reactivate the correct computer system. This incident really highlighted the incredible challenge of maintaining 1970s technology in the harsh environment of interstellar space, where cosmic radiation constantly bombards the spacecraft's electronic systems.
Surviving the impossible, technology beyond its limits.
Voyager 1's instruments should have frozen solid years ago when NASA turned off their heaters to save power, yet they continue functioning perfectly in temperatures that would destroy any other spacecraft. Honestly, the laws of physics suggest Voyager 1 should have died long ago. As the spacecraft's plutonium power source gradually decays, NASA has had to shut down non-essential systems to conserve energy. In 2019, engineers made the tough decision to turn off the heaters that keep the scientific instruments warm in the -270°F environment of space. This should have been a death sentence for the delicate electronics, yet all 5 instruments continue operating flawlessly. NASA engineers are genuinely puzzled by this phenomenon, unable to explain how 1970s technology survives in conditions that would instantly destroy modern spacecraft. The instruments operate in temperatures hundreds of degrees below their design specifications, totally defying every engineering principle. Some scientists theorize that the instruments generate just enough internal heat from their electronic operations to prevent complete freezing, while others suggest that decades of cosmic radiation exposure may have altered the materials in unexpected ways. The spacecraft's resilience has actually forced engineers to reconsider fundamental assumptions about electronics in extreme environments. This unexpected durability has extended Voyager 1's mission far beyond anyone's wildest expectations, allowing it to keep transmitting data from the interstellar frontier where no human technology has ever ventured.
The cosmic radiation bombardment.
Beyond our solar system's protective shield, Voyager 1 faces a constant barrage of cosmic radiation that's, wow, 3 times more intense than anything experienced within our cosmic neighborhood. Interstellar space has revealed itself to be a far more hostile environment than scientists ever anticipated. Once Voyager 1 crossed the heliopause, it encountered cosmic radiation levels 3 times higher than those within our solar system's protective bubble. This intense radiation, consists of high-energy particles accelerated by distant supernova, black holes, and other extreme cosmic phenomena. These particles constantly bombard the spacecraft, gradually degrading its electronic systems and creating cumulative damage that just builds over time. The radiation can actually flip individual bits in computer memory, causing small errors that accumulate into much larger problems. It's honestly like trying to maintain a complex machine while it's being continuously sandblasted by invisible particles traveling at nearly the speed of light. Despite this constant assault, Voyager 1 systems continue functioning through a combination of robust 1970s engineering and clever software workarounds developed by NASA's engineers. The spacecraft's experience provides crucial data about the radiation environment that future interstellar missions will face. Understanding these conditions is essential for designing spacecraft capable of surviving the journey to nearby star systems. Voyager 1 has become humanity's first radiation scout, mapping the dangerous terrain that lies between the stars and providing invaluable information for future deep space exploration.
Software updates across the cosmic void.
NASA engineers regularly send software updates to Voyager 1 across 15 billion miles of space, basically providing tech support to a computer system that's actually older than most of the engineers working on it. Maintaining Voyager 1 requires honestly some of the most challenging technical support in human history. The spacecraft operates with 1970s computer systems programmed in assembly language, a low-level programming code that directly controls hardware components. When problems pop up, NASA engineers have to write new software instructions and transmit them across the vast emptiness of space, where radio signals take over 22 hours just to reach the spacecraft. The engineers use a mix of assembly language and pseudocode to create efficient programs that won't overwhelm the spacecraft's limited 70-kilobyte memory. Each software update has to be perfect. There's really no chance for quick fixes or patches when your target computer is billions of miles away. These updates have solved critical problems throughout the mission, from reactivating backup systems to working around failing components. In one case, a software update saved Voyager 1 from potential disaster by activating fail-safe mechanisms when a hardware component failed. The process requires engineers to think like programmers from the 1970s, using techniques and limitations that modern computer scientists rarely ever encounter. This cosmic tech support is, honestly, one of the most impressive examples of long-distance troubleshooting ever attempted, keeping humanity's most distant ambassador operational out in the depths of interstellar space.
Revolutionary discoveries that changed everything.
Voyager 1's journey revealed that Jupiter has 3 delicate rings. Saturn's rings contain thousands of intricate braids, and volcanoes exist on moons we once thought were totally dead, completely revolutionizing our understanding of the outer solar system. Before Voyager 1's grand tour, our knowledge of the outer planets was limited to fuzzy telescope images and just basic orbital mechanics. The spacecraft's close encounters showed us a solar system far more complex and dynamic than anyone had imagined. Jupiter, which we thought was a calm gas giant, turned out to be a world of extremes, with hundreds of violent storms, glowing auroras, and 3 previously unknown rings that are honestly more intricate than fine jewelry. Saturn's rings, once considered simple and few in number, revealed themselves as thousands of individual ringlets with braided structures that seemed to defy the laws of physics. Most shocking of all was the discovery of active volcanoes on Jupiter's moon Io and nitrogen geysers on Neptune's moon Triton, erupting at temperatures just 40 degrees above absolute zero. These findings totally shattered the idea that volcanic activity was unique to Earth and the inner planets. Maybe most significantly, Voyager 1 identified potential habitats for life on Europa and Enceladus, moons harboring vast liquid oceans beneath their icy surfaces. These discoveries transformed our understanding of where life might exist in the universe, expanding the concept of habitable zones way beyond traditional planetary boundaries. The mission's revelations keep influencing space exploration today, inspiring missions to study these potentially life-bearing worlds in much greater detail.
The eternal journey into galactic immortality.
In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445, carrying humanity's golden record message to any intelligent civilization that might find it. Voyager 1's scientific mission may end in the late 2020s when its power finally fails. But honestly, its journey through the galaxy is just beginning. The spacecraft will keep traveling through interstellar space for millions of years, eventually becoming an artifact of human civilization drifting among the stars. In about 300 years, it'll enter the Oort cloud, a spherical shell of comets surrounding our solar system. After 30,000 more years, it'll completely escape the sun's gravitational influence and start orbiting the center of the Milky Way galaxy alongside billions of stars. The golden record attached to Voyager 1 contains sounds, images, and greetings from Earth in 55 languages, serving as a cosmic message in a bottle for any intelligent beings who might encounter it. This record includes everything from Bach's music to whale songs, from mathematical formulas to images of human faces. The spacecraft has become humanity's first interstellar ambassador, carrying our story into the cosmic deep. Long after human civilization has evolved beyond recognition, Voyager 1 will continue its silent journey through the galaxy, a testament to human curiosity and our drive to explore the unknown. The mission represents more than scientific achievement. It really embodies humanity's eternal quest to understand our place in the universe and reach beyond the boundaries of our cosmic home. From mysterious cosmic humming to impossible electronic survival, Voyager 1's 47-year journey has shown that our universe is far stranger and more dynamic than we ever imagined. This brave little spacecraft keeps rewriting the textbooks of space science while carrying humanity's message to the stars. If you're fascinated by these incredible cosmic discoveries and want to explore more mind-bending space mysteries, go ahead and hit that like button, share your thoughts about Voyager's amazing journey in the comments, and subscribe to Sci and Y for more adventures into the unknown. Thanks for watching. Keep exploring the cosmos.